So in this video, we are going to see what happens when we solve exponential equations. So we're dealing with exponential equations. Now, the first two examples we've done before because we have done common bases before. So when I look at example 1, this is just kind of a quick review. I can change 25 to a base 5. I can change 25 to 5 squared. Once you get those base numbers the same, you drop the bases and set your exponents equal. So n is equal to negative 8. Exponents are not like logarithms. Exponents can be anything, positive or negative. So negative 8 is an acceptable answer. Number 2 is one of the more challenging common base problems because 27 is not 9 squared, but I can change them both to base 3s. 9 equals to 3 squared, and 27 is equivalent to 3 to the 3rd power. So I'm going to replace 9, that's 3 squared, times the exponent that's already there. I'm going to replace 27 with 3 to the 3rd, and I will end up having to multiply that by the exponent that's already there. So I'm going to take this, I'm going to distribute it. Now that I've got like bases, I'm going to distribute that 2, so that gives me 2a plus 4 from the exponent. Since I have like bases, I'm going to distribute that 3 across the second exponent, which would give me 12a minus 6. And then from there, I'm going to solve it. So I'm going to subtract 2a. And that gives me 4 equals to 10a minus 6. I'm going to add 6. I get 10 equals to 10a. So a is equal to 1. Exponents can be anything. So we have our first two review questions out of the way. Now, what happens when you do not have a common base? What if the common base is not possible? Okay, so like in example 3, there's no way I can change 61 because 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, and then 2 to the 6th is 64. There's no way I can change 61 to a base 2. So we're going to have to actually use our calculators this time. So we're going to isolate the exponential expression. We are going to take the log of both sides. You may need to expand the logarithm using the power rule if necessary, and then check for extraneous solutions. Okay, so what I'm going to do is I'm going to natural log, or not natural log, common base log 10 to both sides. I'm going to use my power rule to put x out in front. And then I am actually going to divide both sides by log of 2 to isolate x. So log 2 cancels from the left. So x is going to be roughly 5.9307. All right, here, there's no way I can change a 92 to a base 8 or even a base 2, because remember 2 to the 3rd is also 8. But there's no way you're going to change 92 to a base 2. So what I'm going to do is I am going to log both sides. I'm going to use my power property to drop that power out in front. Now keep that as a group because we're about to move the log 8 away from that. So I'm going to divide both sides by log 8. That's why I wanted you to keep that m minus 7 in a group. So I get m minus 7 equals to log 92 divided by log of 8. And then I'm going to add 7 to both sides. So m is going to equal whatever log 92 divided by log of 8. Get that answer and then add 7 to it, which is roughly 9.1745. On example 5, I need this number by itself, so I am going to divide both sides by 4. So 7n equals 237. I'm going to log both sides. I'm going to use my power rule to put my n out in front. And then I'm going to divide both sides by log of 7. So n is going to roughly be 1.8556. And number 6, first thing I'm going to do is I'm going to add 5. So that gives me 4 to the 3w power equals to 8. Now I'm going to log both sides. I'm going to use my power property to move that in front. So 3w log 4 equals to log 8. Now this time, since everything is being multiplied in that numerator, I'm going to take the 3 with the logarithm, and that will cancel. So on the right, I need to divide by 3 log of 4. So I end up with just w on the left, and then I should end up with 0.5 once I calculate this, because that is what w is going to be equal to. So be very, very careful. If you have any questions, make sure you ask me those questions. Okay. Now, in this particular problem, I am going to subtract 7. So that gives me negative 4 x plus to the x plus 1 power equals to 11. I am going to divide both sides by negative 1 because I do not want that base to be or negative. So 4x, or 4 to the x plus 1, equals to negative 11. Now, when I log both sides, I have to put no solution. You cannot take the logarithm of a negative number. If you try to take the log of negative 11, it's going to give you an error message on your calculator. So always pay attention to that. Make sure the logarithms have positive values attached to them. In example 8, I'm going to divide both sides by 10. So that gives me 5 to the 3k minus 3 power equals to 4. I'm going to log both sides. And then I'm going to use my power property to move my power to the front. Now keep it in a group, remember. 3k minus 3 log 5 equals to log 4. I'm going to divide both sides by log 5. So this one's going to be really tricky to type in. The log 5 will cancel. So I still need to get k by itself. So I have log 4 divided by log 5, and you get 0.8614. I'm going to add 3. So that gives me 3w equals to 3.8614. And then I'm going to divide both sides by 3. So w actually ends up being 1.2871. And that would be your final answer for your exponent. I don't know where a w came from. Don't know why there's a w in my problem. All of those should be k's. I apologize. I just randomly pulled a w out of thin air. And that should be a k there and a k there. I apologize for that misstep on my part. So number 9 and number 10, these are the last 2 examples for this particular video that we are going to do. If you need to see 11, 12, 13, or 14, please contact me and I'll be more than happy to do those for you. 4 times n, or 3 to the n power, equals to, I'm going to subtract 15. So that gives me 344. I'm going to divide both sides by 4 because I want 3 to the n power by itself. Once I get here, I'm going to log both sides. I'm going to use my power property so you can kind of see the way, the pattern that goes with it. And then I'm going to divide both sides by log of 3. Type that in your calculator, and you should get 4.0545 as the value for n. All right. In number 10, I'm going to subtract 7 first. That gives me negative 2 times 5 to the p power equals to negative 70. When you divide by negative 2, you get 5 to the p power equals to 35. And now I'm going to log both sides. Log base 5 or log of 5 to the p power equals log 35. I'm going to use my power property like we've done in almost every single example. And then I'm going to divide both sides by log of 5. The log 5's cancel, and when you take log 35 and divide it by log of 5, you should roughly get 2.2091 for p. So I hope this makes sense. If you have any questions, do not hesitate to contact me.